Hi, Benedicite. For our lesson 2, we will have discrete probability distribution. These are our objectives. To illustrate the mean and variance of a discrete random variable, to calculate the mean and the variance of a discrete random variable, to interpret the mean and the variance of a discrete random variable, and lastly, to solve problems involving mean and variance of probability distribution. You have learned from your previous lessons in mathematics how to find the mean and variance of ungrouped and grouped data. You also learned how to describe data using mean and variance. In this lesson, you will learn how to compute for and interpret the mean and variance of a discrete random or discrete probability distribution. To find out if you are ready in this new lesson, let's answer the following. Given the values of the variables x and y, evaluate the following summations. These are the given. X sub 1 is equal to 4, x sub 2 is equal to 2, x sub 3 is 5, x sub 4 is 1, y sub 1 is equal to 2, y sub 2 equals 1, y sub 3 equals 0, and y sub 4 is equal to 2. Let's evaluate the summation of x. So when we say summation, we will add all the values of x. So we have 4, 2, 5, and 1. So adding them, the sum is equal to 12. So the summation of x is equal to 12. Number 2, we will now evaluate the summation of y. So adding all the y or adding all the values of y, we have 2 plus 1 plus 0 plus 2. So the total is 5. Summation of y is equal to 5. Number 3, we will have the summation of xy. So the summation of xy meaning we will multiply the summation of x and the summation of y. So the summation of x is 12 and the summation of y is 5, and 12 plus 5 is equal to 60. Next, let's have the summation of x plus y. So this means that we will add the summation of x and the summation of y. So the summation of x is 12 plus the summation of y, which is 5. It's equal to 17. Number 5, we will have the summation of 4xy. So meaning we will multiply the summation of x and y and then multiply by 4. So the summation of x and y based on number 3 is 60. So 60 multiplied by 4 is 240. Let's start now with the mean of the probability distribution. So this is now the formula. The mean of a random variable with a discrete probability distribution is, we have the mu. So this is mu meaning mean. So it's equal to x sub 1 times p. So p is the probability times x sub 1 and so on. Or in general, this is what we're going to use. We have mu or mean is equal to summation of x times p of x. So we will add all this. Wherein x sub 1, x sub 2, x sub 3, and x sub n are the values of the random variable x, and p of or p times x sub 1 and so on are the corresponding probabilities. Let's have the steps in finding the mean. Step 1 is to construct the probability distribution for the random variable. Step 2, multiply the value of the random variable to the corresponding probability. And in step 3 is to add the results obtained in step 2, or this is now the summation. Let's have an example. Example 1 is about the number of spots or the number of dots in a single die. Suppose a single die was rolled. We will let x be the random variable representing the number of spots. So we will now solve for the average or the mean number of spots that would appear. So first, we will identify X, or the number of spots. So in a single die, we have 1, 2, 3, 4, 5, and 6. So these are all the numbers in a die. And then for the probability, we have for 1, of course, we only have one 1 in a die out of 6. So the total is 6. So the probability of getting 1 is 1 over 6. And the probability of getting 2 in a die, in a single die when it is rolled, is also 1 out of 6. And for 3, again, 1 out of 6. 4 is 1 out of 6. 5, 1 out of 6. And 6 is 1 out of 6. So remember, when we add all the probability, it should be equal to 1. Next is we will multiply x and p of x. So 1 times 1 over 6, that's 1 over 6. 2 times 1 over 6 is 2 over 6. 3 times 1 over 6 is 3 over 6. 4 times 1 over 6 is 4 over 6. 5 times 1 over 6 is 5 over 6. And 6 times 1 over 6 is 6 over 6. And then we will just add all the values in x times p of x, or we will get the summation of this. So the sum is 21 over 6, or dividing 21 by 6, it's equal to 3.5. So that is now the mean of the number of spots in a single die when it is rolled. Let's have the next example, which is about grocery items. The probabilities that a customer will buy 1, 3, 4, 6, or 10 items in a grocery store are 2 over 10, 2 over 10, 1 over 10, 3 over 10, and 2 over 10 respectively. What is the average number of items, Y, that a customer will buy? So first, we will list all the number of items. Based on the problem, we have 1, 3, 4, 6, and 10. And for 1, the probability is 2 over 10. For 3, it's 2 over 10. 4 is 1 over 10. For 6, it's 3 over 10. And 10 is 2 over 10. And then we will multiply y and p of y. So 1 times 2 over 10 is 2 over 10. 3 times 2 over 10 is 6 over 10. And 4 times 1 over 10 is 4 over 10. 6 times 3 over 10 is 18 over 10. And 10 times 2 over 10 is 20 over 10. And then we will add all y times p of y. So the sum will be 50 over 10, or 50 divided by 10 is equal to 5. So the mean is equal to 5. Next, let's have the variance and standard deviation of the probability distribution. This is now the formula. The variance of a discrete probability distribution is given by the formula. So this is now the symbol for the variance. It's equal to the summation of x minus the mean squared times p of x. And the standard deviation will be the square root of the variance. So if we already solve the variance, we will just get its square root. That is now the standard deviation. So x is the value of the random variable, and p of x is the probability of the random variable, and mu is the mean of the probability distribution. So these are the steps. First is we need to find the mean of the probability distribution, just like what we did on our first and second examples. And then step 2, subtract the mean from each value of the random variable. Step 3 is we will square the results obtained in step 2. And then step 4, multiply the results obtained in step 3 by the corresponding probability. Step 5, get the sum of the results obtained in step 4. So that is now for step 5 is the variance. And for step 6, we will get the square root of the variance that we got in step 5. So let's have the example. So example number 1 about number of cars sold. The probabilities that a local car dealer can sell 0, 1, 2, 3, or 4 cars is 1 over 10, 3 over 10, 3 over 10, 2 over 10, and 1 over 10 respectively. Let x be the random variable representing the number of cars sold. Let's compute the variance and its standard deviation. The first is we need to solve for the mean. So number of cars sold, we have 1, 2, 3, and 4. And then corresponding probability for 0 is 1 over 10. For 1, it's 2 over 10. 2 is 3 over 10. 3, 2 over 10. And 4, 2 over 10. Then we will multiply the two. 0 times 1 over 10 is 0. 1 times 2 over 10 is 2 over 10. 2 times 3 over 10 is 6 over 10. 3 times 2 over 10 is 6 over 10. And 4 times 2 over 10 is 8 over 10. And then we will get its summation to solve for the mean. So for the mean, we have 22 over 10 or 2.2. So the mean of the number of cars sold is 2.2. And after getting the mean, we will need to subtract x and the mean. So this one, 0, 1, 2, 3, and 4 minus 2.2, which is our mean. So 0 minus 2.2 is negative 2.2. 1 minus 2.2 is negative 1.2. 2 minus 2.2 is negative 0.2. 3 minus 2.2 is 0.8. And 4 minus 2.2 is 1.8. And after subtracting x and the mu, we need to get the square of this because this is part of our formula. So we will square or raise to 2 all the numbers here in our fourth column. So negative 2.2 squared is 4.84. Negative 1.2 squared is 1.44. Negative 0.2 squared is 0.04. And 0.8 squared is 0.64. 1.8 squared is 3.24. And after that, this is also part of the formula, this is now the formula. We have x minus mu, or x minus mean squared times p of x. So we need to multiply this column, our fifth column, and our second column. So second column times the fifth column. So 1 over 10 times 4.84 is 0.484. 2 over 10 times 1.44 is 2.288. 3 over 10 times 0.04 is 0.012. 2.10 times 0.64 is 0.128. And lastly, 2 over 10 times 3.24 is 0.648. And then lastly, to solve for the variance, we will just get the sum of the last column. So the sum is 1.86. So actually, we have alternative procedure in finding the variance and standard deviation. So this is much easier. So you need to, or you can use this. These are the steps. So first, we need to find the mean, of course. That's always the first step, find the mean of the probability distribution. And then we will multiply the square of the value of the random variable to its corresponding probability. And then we will get the sum of the results obtained in step 2. In step 4, subtract the mean from the result obtained in step 3. So that is now the variance. And then for the standard deviation, we will just get the square root of the variance. So we will have the example a while ago, which is the number of cars sold. So we already solved for its mean, which is 2.2. Okay, so now we will have the next step. So for the next step, we will multiply the square of x and then p of x. So first, we need to square this first, our first column, before multiplying it to the probability. So square of 0 is 0 squared, so times 1 over 10, so that's 0. And then 1 squared times 2 over 10 is 2 over 10. And then 2 squared times 3 over 10 is 12 over 10. 3 squared times 2 over 10 is 18 over 10. And lastly, 4 squared times 2 over 10 is 32 over 10. And then we will just get the summation of the last column. So the summation is 64 over 10 or 6.4. And for the last step, so this is not the variance, okay? We still have the last step, which is we need to subtract the summation of the last column by the mean, the square of the mean. So we have 6.4 minus 2.2 squared. So this is now the new formula. This is the formula for the alternative solution. So this is much easier. So we have 6.4 minus 2.2 squared, that is 1.56. So as you observe, we got the same answer. And then for the standard deviation, you will just get the square root of 1.56. The standard deviation is 1.25. For your self-reflection, compare the formulas for finding the variance and standard deviation of a frequency distribution and that of a probability distribution. What does the variance and standard deviation of a probability distribution tell us? How do you interpret the variance and standard deviation of a probability distribution? For your self-activity, you may refer to your textbook on page 29 and 43, items A, numbers 1 to 5. That's it. Thank you, and that in all things, God may be glorified.